Okay, so we've got question 2 of the Simultaneous Equations 3 exercise. It says with decimals, so we can expect some of our answers at least not to be nice, neat, whole numbers. Here's the first one. So 10a plus 3b equals 15. 15a plus 4b equals 22. So I'm going to try and make the a's the same. 10 and 15 both go into 30. So why not try and make both of those have a 30a in them. So everything in equation 1, calling this one equation 1, I'm going to multiply by 3. And then everything in equation 2, I'm going to multiply by 2. And that's in order to try and get a 30a in both of them. So equation 2 was that one, by the way. So everything in equation 1 times 3, instead of 10a plus 3b equals 15, that's going to give me 30a plus 9b equals 45. Then everything in equation 2, I'm going to multiply by 2. So instead of 15a plus 4b equals 22, I'm going to get 30a plus 8b equals 44. So the reason I did that was to make the a's the same, so that I could subtract whole equations from one another. Let's call those equations 3 and 4. And I'm going to do equation 3 minus equation 4. So that I get 45 minus 44 is 1. 9b minus 8b is a single b, and 30a, take away 30a, disappears. So b equals 1. Nice easy answer for b, but let's try and figure out what a is. So I'm going to take that b equals 1 and substitute it into equation 1, sub in 1. So equation 1 was 10a plus 3b equals 15. I know that b is 1, so that becomes 10a plus 3 times 1 is 3 equals 15. Take away 3 from both sides to get the a bit on its own. 10a equals, now that's equal to 12. And I don't want to know what 10a is, I want to know what single a is. So divide everything by 10 to get a equals 1.2. So I think the answer is that a equals 1.2, b equals 1, but I'm just going to check that by putting those values into equation 2. 15a plus 4b equals 22, so that's going to become 15 times 1.2. Should I try and do that in my head? That's 18, isn't it? So that's 18 plus, and then 4b, 4 times 1 is 4, so 18 plus 4 equals 22. Well, it certainly does, so we're confident that we've got that one right. Okay, so 1.2 and 1, and then we'll just go on to the next question. So here it is on my board. 4m plus 10n equals 79. I've labelled that 1. 9m plus 8n equals 98. I've labelled that 2. I'm going to try and make, let's make the m's the same. So I'm going to take, well, first of all, 4 and 9 both go into 36. There's nothing smaller they go into. So I'm going to take everything in equation 1 and multiply it by 9. And everything in equation 2 and multiply it by 4 in order to try and get 36m in both equations. So everything in equation 1 times 9. So instead of 4m plus 10n equals 79, I'm going to get 36m plus 90n equals 79 times 9. Bit late at night, so I'm not going to try and do that in my head. 79 times 9 is 711. And then I'm going to do everything in equation 2 here by 4. So instead of 9m plus 8n equals 98, I'm going to get 36m plus 32n equals 98 times 4. That's going to be 392. So I've got two more equations, but this time the m's are the same in both of them. So if I call them 3 and 4, then I can do everything in equation 3, take away everything in equation 4, and the m's will disappear. So let's just do that. 711 minus 392, first of all, that's going to be 319. 90n, take away 32n is going to give me 58n. And 36m, take away 36m, that's just going to disappear. So 58n equals 319. I want to know what n is on its own, so I'm going to have to divide both sides of that by 58. So 319 divided by 58 is what I'm resorting to my calculator for. 5.5. So n equals 5.5. Having figured out what n is, I'm going to take equation 1 and I'm going to substitute the value that I just found, the 5.5, into equation 1. So 4m plus 10n equals 79 is going to become 4m plus 10 times 5.5 is 55. So 4m plus 55 equals 79. I'd like to get the 4m bit on its own, so I'm going to take away 55, but I've got to do that both sides. So that becomes 4m equals 24, and divide everything by 4 to get that m equals 6. So I think m is 6 and n is 5.5, but I'm just going to check that by putting those two values into equation 2. So that was 9m plus 8n equals 98. So that becomes 9 times 6, 54. Plus 8 times 5.5 is 44. 54 plus 44 does equal 98. So we know we've got it right. So over to the iMath screen now, and we'll fill in 6 and 5.5 and go on to the next question. So there's the next question. Equation 1 and equation 2, I've labelled them. So I can either make the p's the same or make the q's the same. Normally I'd make the p's the same. I notice the q's are slightly smaller numbers, so that might be a little bit easier. So for a change, I'm going to try and make the q's the same. So 5 and 6 both go into 30, so I'm going to try and multiply these equations up so that they both have 30q in them. So everything in equation 1 times 6 will give me a 30q, and everything in equation 2 times 5 will give me a 30q. So let's try and do that. So I'm going to take equation 1 and multiply everything by 6. So 16p plus 5q equals 63 is going to become 96p plus 30q equals 63 times 6. That's 378. And then I'm going to take everything in equation 2 and multiply it by 5. So 12p plus 6q equals 45 is going to become 60p plus 30q equals 45 times 5, 225. So I'm calling those equations 3 and 4. And I've achieved what I set out to, which is to have the same amount of q in both equations. So I can subtract whole equations, equation 3 minus equation 4. 96p, take away 60p, gives me 36p. 30q, take away 30q, disappears, nothing, equals 378 minus 225 gives me 153. So 36p equals 153. I just want to know what a single p is, so I'm going to divide by 36. But I've got to divide by 36 the other side as well to maintain the balance. So I want to know what 153 divided by 36 is. 4.25. 4.25. So I think I figured out P, and I am now going to try and figure out what Q is by substituting that value of P into equation 1. So equation 1 was 16p plus 5q equals 63. I now know that p is 4.25, so that becomes 16 times 4.25. 16 times 4.25, 68. That becomes 68 plus 5q equals 63. I want to get the 5q bit on its own, so I'm going to have to take away the 68, but I've got to take away 68 the other side as well. So 63, when I take away 68, leaves me with minus 5. 5q equals minus 5. I want to know what a single q is, so I'll divide both sides by 5 to give me q equals minus 1. So I think that p equals 4.25 and q equals minus 1. I'm going to check that in equation 2. So 12p plus 6q equals 45. That becomes 12 times 4.25. 12 times 4.25, 51. And 6q becomes 6 times minus 1, so it becomes minus 6. 51 minus 6, well, that does equal 45, so that works. 4.25 and minus 1. Okay, next question. So the next question had 6s plus 7t equals 14 and 4s plus 5t equals 11. So I'm going to try and make the s's the same. I notice 6 and 4 both go into 12. So I'm going to try and get a 12s in both equations. So I'm going to take everything in equation 1 times 2 and everything in equation 2 times 3. So equation 1, 6x plus 7,2 equals 14. Multiply everything by 2 and that becomes 12s plus 14t equals 28. And then equation 2, I'm going to multiply everything by 3. So 4s plus 5t equals 11 becomes 12s plus 15t equals 33. So what I've achieved there is to make the s's the same. So I'm going to label those as 3 and 4, and having made the s's the same, I can now eliminate the s's by doing whole equations subtracted from each other. I'm going to do 4 minus 3, equation 4, take away equation 3, because I notice I've got more t's in 4 than in 3. So 33 take away 28 is 5. 15t take away 14t is just 1t on its own, t. And the s's disappear. So t equals 5. sub in 1, 6s plus 7t equals 14 becomes 6s plus 7 times 5, 35 equals 14. Take away 35 from both sides, 6s equals minus 21. So s on its own is going to be, got to divide by 6, minus 21 divided by 6 is minus 3.5. So we think s is minus 3.5, t is 5. We check that in equation 2. 4s plus 5t equals 11 becomes, so 4 times minus 3.5 is minus 14. 5 times 5 is 25. Minus 14 plus 25 does equal 11, so we know that we've got that one right. So over to the iMaths to fill in minus 3.5 and 5. And then on to the last question, which is a word problem. The cost of, well, it's CDs and DVDs. So I'm going to call them C and D. And I'll just go straight over to my pad to get into this, and I'll read out the question on the other side there. So it says in the question, the cost of 9 CDs, so if C is the cost of a CD, 9 times C, and 3 DVDs, so 3D, if D is the cost of 1 DVD, is $82.35. Then it says the cost of 12 CDs and 8 DVDs is $131.40. I don't really need that extra zero there. I've just put it there because it's money. So I'll call those 1 and 2. Okay, so 3 and 8 both go into 24. 9 and 12 both go into, goodness, what do they both go into? So I'm just counting up my 9s. 9, no, 18, 27, 36. 9 and 12 both go into 36. So I'm going to try and multiply these equations up so that I get a 36c in both. So that's going to be equation 1 multiplied by 4 and equation 2 multiplied by 3. So everything in equation 1 multiplied by 4 gives me 36c plus 12d equals, get the calculator on this, $329.4, and then everything in equation 2 multiplied by 3 gives me, instead of 12c plus 8d equals 131.4, it's going to give me 36c plus 24d equals, well, 131.4 times 4 is 394.2. So I'm going to call those equations 3 and 4. I notice I've got more d at the bottom than on the top. So I'm going to do equation 4, take away equation 3. 36c minus 36c disappears. 24d, take away 12d, leaves me with 12d. And 394.2, take away 329.4. I think I'll get the calculator on it. 394.2 minus 329.4, 64.8. So 12d equals 64.8. Divide everything by 12 to find out what a single d is. So divided by 12, d equals 5.4. So we think the DVDs are $5.40 each. Seems cheap. Okay, sub in 1, 9c plus 3d equals 82.35. We know that d is 5.4 now, so that becomes 9c plus 3 times 5.4 is 16.2 equals 82.35. 9c plus 16.2 equals 82.35. Get the 9c on its own by taking away the 16.2. Got to do the same the other side as well. So that becomes 66.15. 9c equals 66.15. I just want to know what c is, so I divide everything by 9. 66.15 divided by 9 is 735. So apparently, in this universe, the DVDs are $5.40, but the CDs are $7.35. Let's just check that in 2. So that was 12c plus 8d equals 131.4. So 12c is 12 times 7.35. Which is 88.2. Plus 8d. 8d is 8 times 5.4. Which is 43.2, and together they're supposed to make 131.4, which they do, so it works, and we can just type those answers into the iMath screen. So 1 CD is $7.35. Whereas a DVD is apparently only 5.4, $5.40. Let's see if we got those right. Yay.